Hey guys, welcome back. This is Miss Carasolis, and today we are at the end of our unit almost. We have some practice days, but this is definitely the last, second to last topic we're going to talk about. We're doing key features, and then we'll do transformations of graphs, and that is it for this unit. And then we're going to test. So, key features of graphs. There's a lot that you probably didn't know about graphs. So up until this point, you've probably mainly discussed y-intercept and slope, and that's about it. But there's actually so much more to graphs than that. We've already looked at domain and range, which is a key feature, and now we're going to look at some other stuff. So here are the definitions. These are in your OneNote, so you don't have to write these down. So we have linear, nonlinear. So is it a straight line or not? The x-intercept, y-intercept. So y-intercept is where it crosses the y-axis. X-intercept is where it crosses the x. Line of symmetry. We're not really going to talk about line of symmetry yet. If a graph is positive, if it's negative, if it's increasing, if it's decreasing, if the relative extremas, and the end behavior. So what happens after you can't see the graph anymore? With the relative extremas, we have a relative maximum and a relative minimum. Then we have our absolute maximum and absolute minimum. We also have independent variables, dependent variables. Your independent variable is just the input value, so your x, and anything that your x is talking about. So essentially when you read a graph, you need to look at the titles and see what it's actually talking about in terms of its word problem. For these first two examples, we're just talking key features. For that third example, we're going to look into an actual word problem graph, I guess you could say. So let's get into it. First one, we have a little chart set up. So it's got the linear, nonlinear, x-intercept, y-intercept, positive, negative, increasing, decreasing, relative extremas, end behavior. So we're looking at this graph. Does it make a straight line? Yes, it does. So it's linear. Next, does it have an x-intercept? It does at 3, 0, right there. And then does it have a y-intercept? Yes, it does right there at 0, 3. So as far as is it positive or negative, this is where it gets slightly confusing, just because you might not understand what that means. So what that means is at my x-intercept, so I'm looking at my x-intercept. When is that graph above the x-axis, so positive on the y values, and when is it negative on the y values? So it is positive when x is less than 3. So let's go ahead and draw a line on here. We're drawing a line through our x-intercept. That way we can see what is this graph actually doing. Then we're going to start at the x-axis and go all the way, scan up. So all those points are positive. Everything from x is less than 3. So when x is 2, it's a positive y value. When x is 1, it's a positive y value. When x is 0, positive y value. When x is negative 1, positive y value. So like that, what is the matching y value? And then vice versa, when we're looking at those negatives, we're going to start at the x-axis and we are going to scan down. So again, any x value bigger than 3 is a negative y value, okay? So I guess that would be a better way of putting it. Where are the positive y values and where are the negative y values? That makes more sense. Okay, so let's get rid of this line. So now when we're talking increasing, decreasing, we are talking about the whole graph from left to right. We always read from left to right. Just like a book, you're reading from left to right. So we're going to go ahead and scan this entire graph. As far as I'm scanning, when I'm going from left to right, I see that the graph is falling. It is falling from left to right. So that means it is decreasing, but it's not increasing ever. So increasing would be none. Decreasing, it's all real numbers because at every single x value, it's decreasing, it's falling. So my relative extremas now, this is Do I have a highest or lowest point? According to these arrows, I don't have a highest or lowest point. So highest or lowest point, I'm looking at those arrows. No, I don't have a highest or lowest points because those are continuing on. They're not really stopping. So again, none. So now I'm looking at my end behavior. Sorry. I'm looking at my end behavior. So looking at this endpoint and this endpoint, if I look, as the x values increase, so as the x values increase, the y values decrease at a constant rate. So that constant rate is your slope. That is what makes something linear, when it has that constant rate. If there's not a constant rate, then it's not a linear graph. And that's really what we're looking for when in terms of linear and nonlinear. So let's look at this parabola. So this is same thing. Is it linear, nonlinear, x-intercept, y-intercept, positive, negative, increasing, decreasing, relative extremas, and end behavior. So this is nonlinear. If you look at the graph, it actually has two x-intercepts, which is okay. So at -2, 0, and 0, 0. And then the y-intercept is at 0, 0. That's where it crosses the y. So again, to figure out this positive, negative, so where my y value is positive, where my y value is negative, we're going to draw a line and another line through my x-intercepts. Scanning up, I can see that my graph is only positive, or I did that backwards. Scanning down, sorry. Okay, so my graph is only positive at x is less than -2 or x is greater than 0, and my graph is negative between -2 less than x less than 0. So between -2 and 0, the graph is negative, that little curve, and then before -2, after 0, the graph is positive. All those y values are positive. Okay. Next, we have increasing or decreasing. So same as last time, we're starting from left to right. So just scanning the graph up until this point, and then scanning the rest of the graph until that point. We can see from the beginning to that midpoint, the graph is falling. So it is decreasing, and then from the middle to the end, it's increasing. So from x is less than -1, it is decreasing. When x is greater than -1, it's going to be increasing. So relative extremas on this one, if we look highest or lowest points, if we look right there, we've got a lowest point. So the curve actually touches at a very low point, lower than anything else. So this is x equals -1. That is our minimum. And now end behavior, we're looking at these endpoints. As the x values increase, the y values increase. Yes, as the x values increase, the y values increase. And also as the x values actually decrease before -2, so -3, -4, -5, the y values are still increasing. So that is that. I know this is a whole lot of key features. Honestly, it just takes practice looking at graphs and breaking them apart. You should be able to get it, but no rush in being a pro yet. You still have time. So now we're going to look at a word problem graph. So this Thunderball roller coaster graph. So this one, if we look at our independent and dependent variable, the independent variable is the x-axis, the dependent variable is the y-axis. So our independent variable would be distance along the track, so how far you're riding on the track. The dependent variable is the height off the ground, so how far is this roller coaster actually off the ground? First question, because with these ones you are going to have a couple of different questions, so you've got to be prepared to answer everything, really break this graph apart. So first thing, what is the y-intercept of the function shown in the graph, and what does it represent? So the y-intercept is 0, 10, meaning when you get on the roller coaster at first, you are 10 feet off the ground. Next, identify a relative maximum of the function represented by the graph. This is where it gets kind of tricky, relative maximums and relative minimums. So relative maximums and minimums are the points where it makes a hill or a mountain. You can see that that point is higher than the rest. There's points on both sides. What that means is that relative maximums and minimums cannot be your endpoints because they have to have points on both sides. So it can't be the endpoints. So for this one, our relative maximums, we have 2. You can always have more than 1. So in this case, we do have 2, and it is the x value. So the relative maximums are at 90 when x is 800 and at 110 when x is 250. So when you've ridden the roller coaster for 250 miles or feet, for 250 feet, you will be 110 feet off the ground. So now let's look at our next question. It says, identify the absolute maximum. So now this is where we want the highest point. So, if there were 2 highest points that were the same height, then that would be okay. But in this case, there's only one. It's this one. This is our highest point. So the absolute maximum would be at 110 when x equals 250. So the highest you're going to get off the ground is 110 feet. You're not getting any higher than that. And then identify a relative minimum. So again, our relative minimum and maximum have to be a curve or like a pointed part. It can't be an end point. So here my relative minimum would be this point down here, which is 30, and that's when x equals 550. Then let's look at this next one. Identify the absolute minimum. So on this one now, we actually do have 2 absolute minimums because we have 2 points where they're the same minimum, and that is at 110. So the absolute minimum would be, 10, not 110, I'm sorry. The absolute minimum would be 10. This shows up at x equals 0, and again at x equals 1250. And last but not least, identify the domain and range of the function. So if I box this in, my domain would start at 0 and go all the way to 1250. So 0 less than or equal to x, less than or equal to 1250. And then, so left to right. Next, we go from bottom to top. So our y's would be 10 is less than or equal to y, which is less than or equal to 110. And these are not all of our key features, but the majority of our key features that we're going to focus on for this next test. We still have one more set of notes, which is transformations. I think those should be a little easier than this, and that's pretty much it. So good luck, guys.